Okay, this is the Unit 6 mastery project on the Unit 6 project progress check FRQ number 1. So number 1 part A asks, state a basic physics principle log equation that the students could use to graphically determine the acceleration due to gravity near the Earth's surface by putting the sphere into simple harmonic motion. And they give you some items that you can use, and it's going to be, you're going to have to use a pendulum. So you can use the period equation for the pendulum. Period is equal to 2 pi root L over G, where L is the length of the string and G is gravity. Let's see. Part B asks, design an experiment so that the students can graphically determine the acceleration due to gravity near the Earth's surface by putting the sphere into simple harmonic motion. So with the equations we find, we can make a little table of the things we need to find. So the first thing we could find is obviously the length of the string, L. Symbol is L, and equipment is just a meter stick. And we can also do the period, and we can time it. Period, which is TP, and we can time that using a stopwatch. And we're using these variables to determine acceleration due to gravity. So all that stuff is G, and we're just gonna isolate G to solve that. So then asks to describe the overall procedure to be used and include any steps necessary, reduce experimental uncertainty, provide enough details, and yeah. So first step is to measure string length. And then you can, to get the period, you can time 5 cycles, then divide by 5. To get 1 period. And this is because it's going to be more accurate this way than just doing it one time, because you could like not time it right that one time. And then you want to make the pendulum where the angle is less than 10 degrees. This is it's like this, something about like the small angle formula or something, where the horizontal component of gravity, which is what's gonna move it in simple harmonic motion, is like close to parallel with the ground, and if it's at too high of an angle, it's not moving at simple harmonic motion anymore. So next you want to use the different values of length, and then you want to test each value 3 times for a total of 9 sets of data in all. Okay. And then that should be it. Let's see. See, we timed it. There you go. Okay. Next part is part C. Okay, this one says indicate below which quantities could be used to graph horizontal axis, vertical axis to determine acceleration due to gravity. So if you isolate the equation of the pendulum, period of the pendulum, t is equal to 2 pi root L over g. For g, isolate that equation for g, you will get g is equal to length over period of pendulum squared. And so when you're making the graph on the vertical, you will have the period of the pendulum, and as the horizontal, you have length. So yeah. See, next part is C2. That's the driving equation. Yeah, so we kind of already did this. So the slope of the graph is just going to be m, which was our g here. So yeah, because we divide these two to get the slope, but that's also the gravity. So this is C1, this is C2. So it's going to be m is equal to L over period of the pendulum squared. And we got that from the equation period of the pendulum equal to 2 pi root L over g. Now for part D, we can, it has to predict the motion of the sphere after the string is cut in terms of the sphere's displacement, initial speed, and acceleration. Okay, and it's cut at point Z. So since point Z is at the amplitude slash max position, they're the same thing. It's going to have a velocity of 0 in that moment. So if you cut the string, then it will have initial velocity of 0, and will have no horizontal velocity, and so it'll just go straight down. So spheres in terms, spheres displacement. So it'll go straight down from where it was without traveling anywhere horizontal. It'll have 0 initial speed, and the acceleration will only be in the y direction, and it will only be due to gravity.